Hi everyone, welcome to this webinar by Mpirical on network slicing. My name's Tom and we've got a lot to go through today, so we're going to go straight into this session. Before we do start though, it's important to note that I will open a Q&A panel for everyone to ask questions in. I won't be taking any from the chat. So we'll have about 50 minutes of a presentation, then 10 minutes for questions and answers at the end through the Q&A panel. So I'll just open that now and feel free to ask your questions as we go throughout. Okay, so let's start on the PowerPoint. So obviously today we're going to be doing a webinar on 5G network slicing, and what we're specifically going to be going through, or our agenda is we're going to be looking at network slicing concepts generally. We're also going to be looking at the network slice template and how the attributes of that can support network slicing. We need to take into account network slice architectural considerations as well. So we're going to be looking at functions that exist within the core that can be utilized to support network slicing and network slicing specific functions as well. We're also going to be exploring how we define a network slice, some network slice orchestration, as a network slice is made up of many different components. Some working examples as well of utilizing network slicing within registration and PDU sessions. And then we're going to top it off with a very small section on slice security. So before we actually start this process of exploring network slicing, I think it's important to understand why network slicing is potentially being implemented by operators. And we can do that by looking at the evolution of the mobile market. So if you look back at 2009 with the rollout of 4G or LTE with release 8, we can see that it's actually quite a consumer-centric market, meaning that we have smartphones and app-orientated services that mobile service providers didn't necessarily benefit on. It was a £1 trillion or $1 trillion market which existed, but not much of that money actually went to mobile service providers. So they needed to look for a way to actually generate additional revenue. The way that they generated additional revenue is through the implementation of things such as narrowband IoT, LTE machine type communication, and dedicated core networks with release 13. So we see an increase in the popularity of machine to machine type traffic increasing, and this is a benefit for the mobile service provider as this is an additional revenue stream. Moving on to 2018, we see 5G new radio starts to be rolled out with release 15. Now this is just the radio access network specifically. This isn't to do with a non-standalone 5G implementation. And at the same time, we actually see 4G surpassing 2G in global popularity. And this may be part due to the narrowband IoT implementation at LTE and dedicated core networks. So at this point in time, in 2018, we see approximately 745 LTE networks and around 10 5G networks. Additionally, in terms of narrowband IoT, we have 74 narrowband IoT networks and 28 LTE-M networks. Now, fast forward to 2024, where we are now, we're hitting that saturation point really for LTE networks. We're at 824. With 5G standalone networks, we're seeing approximately 50. And for narrowband IoT and LTE-M, we're seeing 132 and 61 respectively. But with the implementation of 5G, it's extremely costly. So we can't rely on these traditional implementations for revenue streams. We need to start looking outside the box and finding potential customers. And this is where network slicing comes into play. So what exactly is network slicing then? Well, network slicing is a logical network that provides a specific network capabilities and characteristics in order to serve a defined business purpose for a customer. So this is a logical network that exists on physical infrastructure. On the screen, we've got an example of a network service provider's 5G network infrastructure, and that's going to contain a NG radio access network, next generation radio access network. We've got our 5G core, and we've got our packet data transport network as well. Now, network slicing can be utilized across non-3GPP access networks such as Wi-Fi, but for the purpose of this presentation, this webinar, we're going to be focusing more on 3GPP access. Now, one of the difficulties that we have with network slice composition is that each of these different components, sorry, we've got the packet data transport network there as well. Each of these different components that exist may be purchased from different vendors. So the radio access network may be specifically from Nokia, the core could be from Ericsson, and the transport network could be a Cisco network. So aligning each of these different components to communicate effectively to provide a network slice is a complicated process. And it becomes even more complicated when we start taking into account different network slices. So we spoke about previously how it is a logical end-to-end representation of a network, essentially, a logical slice. And we can have multiple different slices. So on the screen, we've got a network slice 1, which is specifically for internet access. And we have network slice 2, which is specifically for automotive. Now, the more network slices that we have, the more complex and more orchestration is required. As a mobile service provider, we're going to need to manage each of these different network slices, potentially update them if there is any requirements for software or firmware updates. And it becomes an extremely comprehensive and complex process. Now, in regard to a network slice customer, someone that may be purchasing a network slice, it's extremely beneficial for them to have a specific network slice, as from an analytical perspective, they can draw upon different data and different reporting techniques, and we'll explore that later on. As you can see on the screen, we've got our network slice 1 and our network slice 2. We have different characteristics for these slices, so we're going to have different requirements for these slices. And the 3GPP have actually defined a set of 5 different SSTs, or slice service types. As we can see on the screen, we have the 3GPP SSTs, our slice service types, with the first one being enhanced mobile broadband slice type. We have a massive machine type communication slice type, ultra reliability and low latency communication slice type, and that's designed for the low latency and high mobility critical communications. We have a V2X slice type that can support vehicle to infrastructure, vehicle to vehicle, for example. And finally, we have this high performance machine type communications. Now, these aren't necessarily required to be implemented by mobile service providers, but these are some recommendations that have been standardized. So each of these different slices could utilize one of these different SSTs to support the service that it's providing. Okay, so we've looked at the different slice service types, but how as a customer do we actually identify the attributes and the requirements that we need? And we do this through this higher level slice orchestration approach of deploying a network slice. So the example that I'm going to use here is we've got a vehicle manufacturer, let's say BMW, and they have a application server. Now, they actually want some specific network slices or a specific network slice required for an automotive service for their vehicles. And obviously that network slice is going to have to exist across the NG radio access network. It's going to have to exist across the 5G core and that packet transport network as well. So to deploy a slice, what we need is we need a nest, which is a network slice template. And that is all of the attributes that are required for a specific network slice. Now, there's going to be communication between the mobile service provider and the network slice customer around exactly what attributes they require. And this may be back and forth until they actually find specific attributes which are required for their network slice. And we'll explore some of these defined attributes in a second. So the nest attributes are going to be negotiated with that network slice customer and then eventually passed on to the network slice management and orchestration system. Within here, these nest attributes are going to be translated for the next generation RAN, the 5G core, and the transport network, as we may have some information which is relevant to the 5G core, such as potentially spinning up or instantiating new network functions, and we may have some that's relevant to the next generation radio access network and that packet transport network as well. So the network slice management and orchestration job is essentially to take all of the components of the nest and find which components are suitable for the radio access network, which components are suitable for the core, and which components are suitable for the packet transport network. So at this point, we're going to configure all of these different active subnets, is what we call them. And then this will create our end-to-end network slice that BMW in this example can utilize. Now, each of these different areas, these network slice subnets we call them, the radio access network, the core, and the transport network, will have localized management systems which actually manage and maintain that specific network slice subnet. So it's important to note here that the 3GPP don't actually necessarily specify the attributes which can be utilized within this network slice template. They just specify that a network slice template is required to be created in order to generate a network slice. And this is where different standards actually come into play. So on the screen, we're going to have a range of different network slice standards that exist. In the top left, we can see we've got the 3GPP 23.501, which is that system architecture for 5G. And this will contain approximately 50 pages of standardization surrounding network slicing. Network slicing is also going to impact procedures within the 5G system, such as registration or PDU session establishment. So 23.502 will also contain information surrounding network slicing. But the key one we're actually going to focus on here is the GSMA NG.116. Now, GSMA NG.116 is a network slice template suite. It defines those attributes that we require from the network slice customer in order to generate a network slice. I'm not going to go into detail about all of the different network slice standards here, though you will be provided with a free course at the end of this session, which is surrounding network slicing, and there will be more information in there surrounding the additional standards. As it says there at the bottom of the screen, there are many other standards and development organizations involved in network slicing, as it covers a range of different network verticals or market verticals. Okay, so let's dive deeper into that NG.116 GSMA document for generic slice templates. And in here, we really have a range of different network attributes which the customer can actually utilize or specify. So we have the availability, for example, in the top left, and that can specify the minimum availability that they require of that specific service, how much uptime or how much downtime is there allowed to be per year. We can also specify things such as the maximum number of PDU sessions and the maximum number of user equipments registered on that specific network slice. And we're going to explore specifically how that is managed and maintained later on. But there are a range of different attributes that the network slice customer has to ask themselves which attributes are actually the most important to us. Mobile service providers can define their own attributes that aren't on this list and also offer them to customers as well. Okay. So we've spoke about really the approach that we can utilize to communicate with customers, the network slice template and the different attributes that can change. And in a perfect world, customers would actually come and ask a mobile service provider for specific slice. Oh, I'd really love a slice for this specific use case, such as the infotainment system within the back of a car for BMW, for example. But some customers may not actually know that network slices exist. So mobile service providers or network slice providers can actually go to potential network slice customers to identify or to provide them information surrounding what a network slice is, the attributes they can change, and exactly how it would benefit that customer. So in terms of a customer engagement process, we've gone through identifying a potential network slice customer. We can also identify the use cases for this network slice customer and potential associated requirements for that use case. Then we can move on to identifying the key attributes that that customer needs. And that is based upon that generic slice template from that GSMA document that we saw previously. And ultimately, This generic slice template defines all the values and attributes that are required for our network slice template that we pass up to that management and orchestration system for network slicing. So that's what we can see on the screen here. We're passing it to that network slice template, or we're passing the generic slice template attributes to that network slice template. Now, ultimately, that network slice template provides the service level specification, which then will form the basis of a service level agreement. So this generic slice template is basically providing us with a service level agreement, so we understand these are the exact requirements for my network slice, and these are the requirements that need to be met. Now, once all of this has been agreed upon, network slice preparation in terms of preparing resources and instantiation can occur to develop a specific network slice. This is only one approach which can be utilized for customer engagement, is the mobile service provider driven process where they're going out and finding customers. But there are alternative approaches as well. We have a self-provisioning approach where a network slice customer can utilize a web portal online to configure and set up a specific network slice for themselves. And we also have a pre-provisioning approach where the mobile service provider already provisions a network slice and then goes to customers to sell that network slice. So we don't have that service level specification discussion. That service level agreement is already there with that specific network slice that exists. And examples of this could include an esports package where we have different tiers of network slices, a bronze, silver, and gold. And the bronze package could have a lower bandwidth than the gold package and more lenient latency requirements, whereas the gold package could be quite strict on a minimum level of latency that's required. So there are a range of different ways that customer engagement process can actually go. Okay, so let's have a look at an example of a nest for one of the common use cases for network slicing. And this use case ultimately is enhanced mobile broadband and IP multimedia subsystem support, which is a very common use case that's been identified. So we need to remember that resources for this specific network slice are going to be separately managed from other network slices. And we have some requirements of this network slice. We need the ability to access the internet, and we need the ability to access the IP multimedia subsystem for voice and video. So we're going to have to establish a minimum of 2 PDU sessions. So within the second PDU session, as you can see on the screen, we're going to have a QoS flow specifically for the IMS signaling, and we're going to have a QoS flow for voice. Now, this network slice is essentially going to consist of this to allow us for the access the internet and for the voice over new radio services. But let's have a look at what that nest would actually look like for this specific network slice use case. So we'd have a discussion around the availability which is required, and it's not necessarily a high availability. We've got 5 nines of availability, and that's approximately a maximum of 5 minutes and 15 seconds of downtime per year. We also need to support multimedia telephony. So that is a requirement to access the IP multimedia subsystem. It's essential that that is supported by this network slice, which is shown on the screen. Apologies. We also need to support session and service continuity. So this is set as mode 1, means that the PDU session will remain anchored to a specific user plane function. So as a device or a user equipment travels throughout the network, whether that be a mobile phone or a car, for example, they're going to always be anchored to the same user plane function, and they're always going to maintain the same IP address. Now, finally, we're also going to be exploring the slice quality of service. So in the value column, we can specify these 5 QIs, which is a 5G QoS flow identifier. And each of these values have a certain set of parameters with it, such as the priority of communication, whether it is a guaranteed bit rate or a non-guaranteed bit rate approach. So we can see that 5QI1 is for voice, 5QI2 is for video, 5QI5 is for IMS signaling, and 7, 8, and 9, 5 QIs for different types of quality of service when accessing the internet. This is essentially all of the different attributes which are going to pass to the mobile service provider within that network slice template. Okay, so far we've gone over network slice concepts, we've gone over the network slice template. Now it's time to dive into the network end-to-end architecture. So we're going to explore some of the standard 5G elements which exist and some network slice elements which exist. It's important to note at this point that for network slicing to actually utilize, it needs to be a 5G standalone system. So on the screen, we've got our user equipment and the data network. Now, the representation here is a mobile phone, but the user equipment could take on many different form factors depending on the use case scenario. And it's the same for the data network as well. So ultimately, what we want is we want a PDU session established between that user equipment and that data network across the user plane, passed from that G node B, that radio access network, onwards towards the user plane function, and then to the data network. Now, we also have additional functions that exist within the core, and we've not specified every single one here. But it's important to note that all of these functions, these normal functions that exist within the core, need to be slice aware. They need to understand what the concept of network slicing. So we have our AMF here, our access and mobility management function, and that deals with the registration of devices and mobility throughout the network. We have our session management function, and that supports the establishment of PDU sessions, so that needs to support slicing as well. We have our UDM, which is our Unified Data Management, and that is a centralized repository of subscriber and data information, and that will contain information surrounding what specific slices, what certain user equipment can actually connect to. And remember, all of these need to be slice aware. It's important to note as well that the AMF must be involved with all of the network slices that that device is allowed to access. And we'll discuss in a second specifically what happens if it isn't. So the first network slice specific function we're looking at is the NSSF, that is the network slice selection function. And the role really of the network slice selection function is to support that AMF if an AMF is unable to support the slices that user equipment wants. So the AMF will communicate to the network slice selection function. It'll say, I'm not able to support the slices that its user equipment is requiring. Please can you find for me an AMF that supports all of the slices that this user equipment wants? So the NSSF will go away and it'll find an AMF and refer it back to the current AMF, and the registration process will continue. We've also got the network slice admission control function, and this is essentially a glorified counter within the 5G core. Its responsibility and its role is to count the number of registrations that exist on a specific network slice, and also to count the number of PDU sessions which are established on a specific network slice as well. So during the registration process, the AMF may query that network slice admission control function and say, okay, this user equipment is signing up to the specific network slice or registering on this specific network slice. Add 1 to that counter that you're storing of the number of registered devices. The NASCF can send 2 results back. It can send a 204 no content and specify, great, yep, that's been done. I've added 1 to the counter. But if it actually sends a 200 OK message back to the AMF, or responds back to that AMF, it can say, actually, this network slice is currently full. So even though that user equipment is allowed to register on this network slice, we're actually at maximum capacity. And the same can be done for the establishment of PDU sessions as well in the session management function. Now, although the NWDAF is not network slice specific, it allows other network functions within the core and also external application functions to actually query the core to identify if that service level agreement is being met, or identify if there are any issues with the network slice which has been provisioned. And so it's extremely powerful when it comes to network slicing, as we can have specific granularity surrounding data about one specific slice. Finally, we've got the NSSAAF, and this is the network slice specific and standalone non-public network authentication and authorization function. We're not going to go into too much detail about this specific function, but it's just important to note that during the registration process, this can be utilized to communicate with an external AAA server, so that's an authentication, authorization, and accounting server, for an additional level of security to make sure that that device truly is allowed to be registered on that network slice. Okay, so let's move on to the network slice selection function first and look at its duty in more detail. I'll look at its responsibilities in more detail. So the network slice selection function has one of its roles is the selection of slice instances. So when a device actually registers to the network, it needs to understand what slices it can actually access. And this is called an NSSAI. This is a network slice selection assistance information. That's a list of all the network slices that device can access. In addition to this, the network slice selection function provides NSSAI management. So network slices may only be allowed in certain areas, and so it supports the process of identifying if that user equipment is allowed to utilize that network slice within a certain area. We also spoke previously about determining an AMF set, so if the initial AMF which is being utilized during registration can't support all the requested network slices of that specific device, then the NSSF looks for an AMF or a set of AMFs which can support that. And finally, the network slice selection function can actually apply network slice restrictions based off data analytics it receives from the NWDAF. So this could be related to certain load levels. It may restrict certain users from accessing specific slices due to load levels on a specific network slice. Now, it's important to note here that in some implementations of network slicing, you may not actually see the NSSF. And that's because the AMF and the UDM together can potentially do these roles. In terms of network slice instance selection, the selection of slice instances and NSSAI management, that can be done by the UDM. And determining the AMF set and the network slice restrictions could potentially be done by the AMF. Okay, let's move on to network slice admission control function. So the network slice admission control function, as I previously noted, is essentially just a glorified counter within the 5G core. Its key responsibilities are tracking or restricting the number of devices registered on a specific slice, and also tracking and restricting the number of PDU sessions per slice. So it's just counting the number, and if we're reaching, for example, let's say on our specific slice, we're only allowed 250 PDU sessions. If we reach that value and the SMF tries to establish a new PDU session and notifies the network slice admission control function, it will return and say, nope, that PDU session is not allowed to be established, we're at capacity. The network slice admission control function also has a service-based interface that allows external application functions that are outside of the 5G core to query about the specific load levels of, or the specific amount of devices which are registered on to the network slice, and the specific amount of PDU sessions which have been established on that slice as well. And that's to support that service level agreement. Now, slice analytics. So I specified that the NWDAF, network and data analytics function, is not specifically for network slicing, but it can be used to obtain a large amount of data. So the NSSAI, which we'll explore later, as you can see on the screen, that's a single network slice selection assistance information, and that is a specific network slice, is going to be sent in a load level information message from the network function or a consumer network function. We can also specify the network slice instance ID as well, and this is an optional field. And we can specify an area of interest, the network function types that we want to look at, and the load level threshold of those network functions. So for example, we could query the NWDAF and say, okay, we want to look at this specific network slice. We want to look at it within this area. We want to look at only session management functions and tell us the load level of session management functions that are over 70% load. So the role of the NWDAF is essentially then to collate all of this information from different sources, whether that be the operation and administration and maintenance systems that exist for the 5G core. So that allows us to identify the mean number of registrations or the specific number of registrations at certain times of the day. But we could also query specific functions within the 5G core, such as the access and mobility management function, the session management function, and the network repository function. So the NWDAP is going to collate all of this information and extrapolate upon the data that it finds and send that output analytics towards the network function, which is the consumer. Now, this could be an external application, remember, it doesn't necessarily need to be within the 5G core, but here it's providing information about the network slice instance load, the network slice load, and some predicted loading as well, what the load may look like in the future. This isn't the only information that we can obtain from the NWDAF. We can obtain a range of different information surrounding the slice load level, observed service experience, QoS sustainability. There are a range of different ones that you can see on the screen there. And these can be analytics for a specific slice. So that filtering is really important. Okay, so let's move on now to network slices, network slice instances, and network slice subnet instances. So a network slice is a generic term that we give for that logical representation across the 5G system. But a network slice instance is actually an instance of that blueprint, which was that network slice. So on the screen, we've got our 5G access network and we've got our 5G core. And our network slice instance is going to consist of multiple network slice subnet instances. So we're going to have an NSSI for the access network, and we're going to have an NSSI for the core network, and one for the transport network as well, potentially. So as you can see on the screen, we've labeled the NSSI for the access network as AN1, and for the 5G core, we've labeled it as CN1. So our network slice instance is a grouping of these NSSIs. And obviously this is the transport network is going to support the communication and connectivity between these different NSSIs. Now, in the real world, we may have many different network slice instances running over a 5G system. So on the screen, we've got different communication services which user equipment may want to use. And we'll have different network slices which can be utilized for those communication services. So on the screen, we've got our NSIA here, and we can see that it's got that AN1 and CN1 for the network slice subnet instances, and that can communicate with the communication service instance 1. And we can also specify here maybe that we want it to communicate with service instance 2 as well. We have a second network slice instance, which are NSIB, and that consists of the NSSI for the radio access network, and that is the AN2, and the NSSI for the core network, which is CN2. So you can see that these are logically separate network slices, and that's only allowed to communicate with that service instance 2. And that can be specified within that network slice template, and the attributes there, we can specify what data networks or not service instances that network slice is utilized for. And finally, we've got this network slice instance C. And we can see here that it's sharing that NSSI, that access network 2, with the NSIB. So depending on the requirements of a network slice, we may actually be able to reutilize or utilize at the same time the same NSSIs. It depends on the data which is being sent across the network. So for example, NSIB may be sending sensitive data, or they may be specifying that they want a logical separation of that slice. Whereas NSIB and NSIC may be more focused around cost, the implications of having their own logically separate network slice, and they realize it's not particularly a requirement for them to have it logically separate. So they're reducing the cost by sharing that NSSI. There could be issues that come up later on in terms of configuration of that NSSI if two different communication services are actually utilizing it. Now, NSSAI, Network Slice Selection Assistance Information. And we mentioned before, that's the means by which we control a device to access a group of network slices. It's the list of network slices a device is allowed to access. So on the screen, we've got our NSSI, and that is comprised of multiple SNSSAIs. Now, an SNSSAI, a single network slice selection and assistance information, is the means by which we identify a specific network slice. So each of these different SNSSAIs correlates to a different network slice. So what does this SNSSAI actually comprise of? Well, as mentioned, it uniquely identifies a network slice, but we've come back to this SST that we saw previously, this slice service type. So one component of the NSSAI is the slice service type and the characteristics that it has. And I'll put a list of that on the screen now, just for memory purposes. So we could specify here that this NSSAI has the SST value of 1, meaning that it is an enhanced mobile broadband specific slice. And in addition to that, we also have something called a slice differentiator. Now, the slice differentiator ensures that if we have multiple NSSAIs with the same SST, the slice differentiator will be different, so we can identify this for a different network slice. So the example that I can give here is we could have an SST for an infotainment system, once again in a car, but the slice differentiator specifies that that specific one is for BMW. And we could have another SNSSAI, and that has the same SST, but the slice differentiator specifies that that's for Ford. So it allows us to have a one-to-one mapping of NSSI to a network slice instance. There are certain configurations where you can have multiple NSSIs to connect to one network slice instance, but the SST has to be the same for all of those NSSIs. Now, there are different types of NSSAIs. We have a configured NSSAI, and that's up to 16 SNSSAIs, which are stored on the device. So this could be pre-configured when the device has been built, or it can be passed down by the 5G system in a UE configuration update procedure to notify them you are allowed to access these specific network slices. So in this instance, let's say we've gone with the configured during the production approach. The device is going to send up a requested NSSAI, and that's up to 8 NSSAIs maximum. That's what's been specified by the 3GPP. You're allowed up to 8 NSSAIs and a maximum of 15 PDU sessions. So this is going to be sent up through the registration request, and that is going to be sent to the AMF. The AMF is then going to check the UDM to say, okay, the device has sent up a requested NSSAI list. Let's check what we've got stored to see if the device is actually allowed to access that. And that is the subscribed SNSSAI stored within the UDM. And that is up to 16 SNSSAIs. You can only have 16 SNSSAIs per public land mobile network for each device. So the UDM is going to provide that information to the AMF. The AMF is then going to have the list of the requested network slices the device wants to connect to, and the list of the allowed ones it's allowed to connect to. And the AMF is then going to communicate back to the user equipment and specify, here are the actual SNSSAIs you're allowed to connect with. So from this point onwards, the device is only allowed to connect to those SNSSAIs that have been specified by the AMF. It may not contain all of the ones that the requested NSSAIs sent up. It could only contain a subset of them if the device is only allowed to connect to a subset of those network slices. Okay, network slice instant management. So we've gone over this preparation phase already, the design, the onboarding, preparing an environment, but we really need to focus on the life cycle of a network slice instance. And the first component of that life cycle is the creation of a network slice. So we need to understand that relationship between the provider and the customer. Do we actually need to create a new slice? If we have one already, can we just utilize that one? If the answer is no, we need to create a new slice, then we need to go into this commissioning phase of a network slice. And we'll explore how that operates later on. We also have the operation phase, and this is when a slice is operating. So we can either activate or deactivate a slice in this phase. Deactivation, we're not deleting that slice, we're just putting it into an idle state. During operation, we also need to think about supervision, reporting, and modification. So we can supervise our network slice, we can identify any issues and modify that network slice. For example, we may actually be paying for more resources than we're utilizing, so we could reduce the amount of resources we're utilizing. We can then check to see via reporting if this modification has actually been adjusted successfully and the network slice is still working as intended, and that can feed back into that supervision process. And finally, we have this decommissioning phase as well. Within the decommissioning phase, this is the termination of a network slice. So we're going to deactivate it, make sure everyone's off the network slice, and then we're going to terminate that network slice, delete it. Okay, so for the commissioning aspect, let's have a look at slice instantiation, how we actually create a network slice. So the terms that are utilized in this diagram are quite broad. We've got the NSMS, and that's a network slice management system. We're going to have one for the consumer and one for the provider. We've got the NSSMS for the transport network, the core network, and the radio access network, and that's the network slice subnet management system. And the reason this is broad is, once again, because the implementation varies depending on mobile service provider. But for the transport network, we're probably going to see an SDN controller. For the core network, maybe a management and orchestration controller. And for the radio access network, we're going to see a RAN controller. But as an NSMS consumer, what we're going to do is we're going to send up an allocate NSI request. And this is going to contain the service profile attributes, essentially our network slice template that we saw previously. So this will contain the SST, that slice service type. It'll contain performance attributes such as latency, availability, reliability. It may even contain the requested device restrictions, such as the maximum number of PDU sessions, or specific public LAN mobile networks that this network slice is allowed to be utilized on. So the NSMS provider is going to obtain this list, this service profile attributes. And at this point, it's going to decide, do I need to create a new network slice instance? Or can I utilize one that already exists? Does it match this service profile requirements? And if it does at this point, it can communicate back to the NSMS consumer and specify, okay, we've already got a network slice which actually meets these needs. So we're going to point you in the direction of that network slice instead. If the NSMSP, the provider, actually thinks it needs to create a new network slice, then we're deriving those network slice subnet instance requirements. So remember we saw previously about the management and orchestration and turning those nest attributes into specific attributes for each of the different subnets. This is what we're doing here. So it's going to identify all of the different attributes which are required for the transport network, the core network, and the radio access network. And it's going to communicate them using, remember, an allocate NSSI request, not an NSI, an NSSI, an allocate network slice subnet instance request. Now, at this point, the transport network, the core network, and the radio access network are going to perform NSSI allocation. So they're going to allocate all of the correct amount of resources that is required for that specific network slice instance, such as spinning up the additional functions within the core that we use as an example previously. And then the allocate NSSI response is going to be sent back. And that's going to contain all of the information that we need to create our network slice MOI. That's our managed objects instance. And that is our network slice now. We've got that there. So we need to communicate back to the consumer about what we've created. And we do this in an allocate NSI response. This is going to contain a network slice IOC, an information object class. And that's a definition of what has been created for that consumer. So if we compare that against the service profile attributes, as the attribute list will be in this IOC, we can see if there are any disparities there that have been changed. And that may be based on certain restrictions within the network. In addition to this, the consumer is also going to be provided with a network slice distinguished name. And this is an identifier, an ID for that specific network slice. And that's that network slice ID we saw previously. Okay, let's have a look at how network slicing impacts registration. So here we've got a registration procedure, which is network slicing focused. We've got our user equipment. And during the registration procedure, it's going to pass up that NSSI list. And remember, that's going to pass to the G node B, and the G node B is going to pass it onwards to the AMF. So this requested NSSI could either be the configured, remember that the device has been pre-configured on it before it registers, or it could be an allowed list. If it's registered to the network previously, and this is a subsequent registration, it could use that allowed list. The AMF on this point onwards is going to download that subscriber profile for the registration process. And within there, we're going to have a list of network slices that that device is actually allowed to access. So the AMF is going to compare the list it's received from the user equipment and compare the list it's received from the UDM and check to see if that device can actually access the network slices it's requesting. Now, there's an optional stage here, and we discussed this briefly previously. But if the AMF isn't able to support all of the requested NSSAI, the AMF can query that network slice selection function in order to find an AMF which can support that specific subscriber. So the registration process will continue on with a different AMF that can support all of the network slices that user equipment wants to connect to. Okay, so let's have a look at PDU session establishment. So at this point, the network is already aware of the slice and the device is registered and has its allowed NSSAI list. But one approach we can actually utilize is USRP provisioning. So this is UE route selection policy provisioning. And what we're doing at this point is we're communicating down to the device that if you want to use this service or you want to communicate with this specific data network or this specific application or service, utilize this specific SNSSAI. So when you want to access a specific application or service, use this specific network slice instance. And that's what we're communicating down to the device. So when the device wants to establish a PDU session, it already knows what SNSSAI it needs to use. So we've got here the G node B is pre-configured with the NSSAIs, including the slice characteristics. The PDU session establishment request is sent up from the user equipment all the way to the AMF. Now, at this point, the AMF needs to find a SMF which it can utilize or which supports that specific network slice. So it queries the network repository function. Now, as the name suggests, the network repository function holds a repository of all the different functions that exist within the 5G system. So we can specify, I'm looking for an SMF, I'm looking for it to support a specific slice. Please, can you find me that information? So at this point, the network repository function will communicate back to the AMF and say, okay, this session management function supports that specific network slice that that device wants to connect to. And from that point onwards, we can establish user plane path and that PDU session can be put in place. So that device will be communicating with that data network or that service within that data network on that specific network slice using a PDU session. Now, we have a little bit of a section here on slice security, and it's specifically on slice isolation. We have 3 different types of slice isolation that exist. It's not just specifically security. We've got performance isolation. So a network slice customer may only may want a isolated slice so that they know and ensure that the resources they're utilizing are actually going to be provide a guaranteed level of performance. If they're sharing a network slice with another company or another service, there may be issues there with a guaranteed performance. We also have management isolation. So some network slice customers may like their own network slice because it allows them to independently manage and configure. If we have two customers utilizing the same network slice, there may be issues when it comes to configuration and clashes about configuration. And finally, what we've got is security isolation. So this is a separation of slice for security purposes, such as preventing unauthorized access, supporting them, or reducing the modification of data, processes, and services and functions, as it says on the screen. And this could be split into two different approaches. We can have a physical security isolation, and that's expensive for network slice customers. And we really don't see this implementation. This is essentially a private network. Or we can have the logical security isolation. And that's where, and that's where we've got that logical, that's not allowed to be part of any other network slice. The network slice subnet instances will be only utilized for that specific network slice. So that is our sort of whistle stop tour of network slicing. If anyone has any questions, please put them in the Q&A tab that is on the right-hand side of the screen. I'm going to return to the tab of my face. We'll go there. Hopefully you can see me now. So if anyone has any questions, please let me know. I'll collect them now. And while those sessions are coming in, I'm going to just go onto this screen. Sorry, apologies. While these questions are coming in, I'm going to go onto this screen. Anyone who's attended this live is going to be receiving free access to the follow-on training course, which is the 5G network slicing and the NetX tool that comes with it. If you we'd really appreciate if you give feedback on this course. There's just a QR code, or this webinar, there's a QR code at the bottom of the screen. So we'd really appreciate if you answer the short questions that come with that. Okay, so I'm just going to go back onto the slide with my lovely face, and then I'll start answering some of the questions that come through. So the first question, can a single slice have only one SST at a time? Yes, a single slice can only support one SST at a time, correct? So the next question is from Anonymous again. How exactly the user equipment uses the accepted NSSI after registration? So this accepted NSSI list after registration is going to be used for PDU session establishment. So we can specify within that PDU session establishment request what specific network slice we actually want to connect to. I hope that answers your question. Could you explain the relationship between SST and slice attributes? Oh, apologies, I should put this on the screen if it'll fit. Yeah. Could you explain the relationship between SST and slice attributes? I've understood that the network slice template defines the slice attributes. So what is the relevance of the SST? Are there default attributes for the SST? Yes, so that there are default attributes for specific slice service types, but the network slice template provides additional optional attributes which can be utilized for that specific network slice. So it's taking that granularity of customization a step further, essentially. Okay. So what are the minimum requirements for user equipment to request different slices in terms of 3GPP release? And how would it work in case the UE is allowed more than one slice? So a UE is allowed to connect to a maximum of, or can request a maximum of 8 slices at once with 15 PDU sessions. In terms of the minimum requirements for a user equipment to request different slices, I'm not particularly sure. I'm happy to speak to you after this webinar if you want. We can talk over email and I can find the correct answer for you, but that's a really good question. Thank you very much. Okay. Apologies, my interface is lagging a little bit. So once a PDU session has been created, can PDU session modification be used to change the slice it's using? No. So a specific PDU session will be for that specific slice. If you want to utilize another slice, you're going to need to request a new PDU session. Okay, can the network slice selection function force the selection of a new AMF for a user equipment in the case the AMF cannot serve all the slices needed for the user equipment? So if an AMF can't support all of the slices needed for that user equipment, it has to give up or it has to find a new AMF. So yes, the network slice selection function does support that process. It will find a new AMF to pass over the user equipment to and carry on that registration. The AMF needs to support every single network slice that device wants to connect to. So Lily says, which user equipments are supporting URSP in the market? I'm not particularly sure with this question, to be honest. I think all of the devices are. It's just UE capabilities. So you're just passing down to the device basically a set of policies about what slice that device should utilize for what service it should be on. The issue is we don't really see many network slices at the minute. So you're not going to be seeing sort of a lot of this type of messages down to user equipment. Just scroll up a bit more. So we got a message here from Tejas. How can network slicing be used in autonomous systems? So in terms of autonomous systems for vehicles, we can obviously use the SST V2X type. It can be utilized for a range. We could have different network slicings for different approaches. So we can have a network slice that is for the sensors of an autonomous vehicle, and we could be reporting information back to a centralized database or centralized data network, meaning that we're going to need high reliability and ultra low latency communications so that that device that's communicating is going to be sending sensor data to a network, calculations are going to be made, and information is going to be sent back to the car to make decisions. So we could have a network slice specifically for that. But also within autonomous vehicles, we can have a slice for updating and configuring a car, for example. So that could be a very similar to sort of an IoT type slice, where we're not going to be sending in much data, but the updating process is going to be very short. Apologies, the updating process is going to be very minimal, maybe once a day, for example. So we don't need high bandwidth on that slice, and we're not very time focused. We could then have an infotainment slice in the back of the autonomous vehicle for the infotainment system. So we're expecting not really a requirement around latency, but we want high bandwidth. I hope that answers your question. So Emma Up says, internally, is 5G slicing accomplished using standards like the 802.1q, differentiated services, or has 3GPP standardized new methods to accomplish slice isolation and quality of service control? So I think this is dependent upon which area of the network you're utilizing. Within the core network and the radio access network, it's going to be different from the transport network requirements. I'm not particularly sure on if it's utilizing the 802.1q standards and differentiated services, but I'm more than happy to speak with you afterwards via email, and we can have a chat and find exactly what that is. Next question is, can I get recording of this session? Yes, I think this session is being recorded, as some people may not be able to attend the webinar, so people will be sent a recording. How can slicing be used in autonomous systems? I think I've already answered that. What are the challenges of implementing network slicing? So there are a range of different challenges for implementing network slicing. And I think the main one that we see is orchestration between that radio access network, the transport network, and the core network. We need to make sure that that level of service, that service level agreement which has been put in place in the network slice customer and the network slice provider or the mobile service provider is actually being upheld. And there are a lot of complications, especially with what we discussed previously about how the radio access network, the core network, and the transport network may be purchased from different vendors, and making sure that there is some form of collation between each of those different components. So the main challenge that I can see is sort of that cohesion between each of the network slice subnet instances. Someone else has asked the recording of the session. Yes, there will be. Do you expect network slicing to be available in roaming scenarios? Probably just put this on the screen. Do you expect the network slicing to be available in roaming scenarios, especially on roaming partners, radio access network, to support certain slices? Network slicing will definitely be available in roaming scenarios. There are situations, for example, that network slicing can support, such as the offloading of data from airplanes. So an airplane may fly from one country to another and land, and it may need to offload data or specific flight information data. And that requires, if we've got a specific network slice for that service, that requires that availability of allowing roaming scenarios. So it's definitely important that network slicing will be supporting roaming scenarios, and it definitely will, and it definitely does. I hope that answers your question. Okay, I don't have any more questions now in the Q&A. So thank you everyone for watching the webinar. I'm going to put this on an any other questions screen now, and I'll wait here and I'll answer questions in the normal chat. I hope you've all really enjoyed and have a good day. Thank you.